In outback Australia, it's everywhere, but not always welcome. Spinifex grass is tough, spiky and of not much use to farmers. But for thousands of years, Indigenous Australians have used this ubiquitous plant for medicine and glues. And now researchers in Queensland's far west believe resin from the grass could be used to make new building materials, with the potential to revolutionise the way houses are constructed in the Australian desert.
Just 20 clicks from the Northern Territory border, the rugged, arid terrain of Camooweal in Western Queensland can be an uninviting environment. Even in winter, it's hot out here and it's flat as far as the eye can see. And to the untrained eye, it's not what you'd call a pretty place. But to Professor Paul Memmott, this is God's own country.
Some pungents are certainly producing resin. I might take some back for our chemist. We're getting a new chemist from Iran. We might take some of this back and get him to analyse the resin in it.
An anthropologist by trade, the professor has spent much of the last 35 years of his career between the far western reaches of the Sunshine State and the deserts of Central Australia.
I don't know. What Malcolm stick in the scale?
Oh, you know, it's just on the leaves.
How much glue or how much, not enough glue?
The extent of the resin all over the leaves.
A native title claim just outside of Camooweal a decade ago brought him in contact with traditional owner Colin Saltmere. And once the native title issue was resolved, the pair started working on a long-term plan to better life for the region's Indigenous population.
One of the things I've been very interested in doing in my career is getting enterprises developed or helping Aboriginal people develop enterprises. And we suddenly thought of a way that could catalyse a type of cottage industry or an agricultural industry for Aboriginal people in remote parts of Australia. If they could sustainably harvest Spinifex grass, which covers at least a quarter, probably a third of the continent, and at the same time if we could find a commercial use for Spinifex. And the idea was to draw on the Aboriginal knowledge to inform the scientific knowledge and make a partnership in the project with scientists from the university and Aboriginal people in this region. Did you check those to see whether the...
As the director of the Aboriginal Environments Research Centre at the University of Queensland, the venture was a good fit. Now, about 30 people are working on the project, mainly ecologists and botanists who are looking at the reproduction and regrowth of the plant in its natural environment, as well as how it propagates under different weather conditions. The research area takes in 3 plots in Camooweal and 2 more down the road at Dajara.
So in this plot, we have 25 plots, each 10 by 10 metres. We have 5 different treatments. Winter harvest, winter burn, summer harvest, summer burn and 5 controls. So we are looking at what's coming up after those harvesting methods, whether there is more regrowth after winter harvest or whether there is more regrowth after the summer harvest.
There are 67 known species of Spinifex and only a handful have been researched to date. But it's been used by Aboriginal people in these parts for thousands of years.
It belongs to country, and we've been using it for a long, long time. You know, it's a medicine. It's a glue, an adhesive. You know, we use it on all our artefacts, making spears and knives and boomerangs and chisels and all that sort of stuff. So it you know, it's just like a glue that you use today, what they glue things together, but we were using it way, way back then.
So the idea actually came from them. So currently in this project, what we are looking at is to use those traditional knowledge, combining modern Western knowledge and make them more sustainable use of as a building material.
At the Myuma Group's work camp outside of Camooweal, trainees are not only learning about Spinifex properties, but also help out with some of the research, combining the old knowledge with their modern learning in construction and horticulture. In desert areas, Spinifex cladding on domes was laid on up to 2 metres thick to protect families from both the freezing cold and the blazing heat, and also proved to be very good at shedding water. These properties have the scientific world in a flurry, and it's this resin that has ears pricked sharply. It's by no means clear what the actual function of the resin is, and is somewhat of an ecological mystery. A lot of work is being done to look into the idea that ants actually play a part in triggering the resin production. That fire process results in a malleable putty-like substance that when heated up can be moulded and used just like a cement. For a natural product, its durability and strength is somewhat of a marvel. A world away from the rugged terrain of the outback, the Spinifex is being marvelled over in detail at the Australian Institute for Bioengineering and Nanotechnology, based at Brisbane's University of Queensland.
The interesting thing about Spinifex resin is that it's thermoplastic material, so as the Indigenous people have shown, you can heat this material up several times and work with it like putty. That's really interesting to us, so we're exploring that and trying to understand that a bit better. We can also add additional things like cross-linkers in there and change the mechanical properties as you would with an epoxy resin or that type of synthetic polymer. So there's a couple of different aspects there.
Researchers believe that the resin, being like a natural glue, could replace synthetic resins in the building industry altogether.
We're also looking at the fibres. As I said, the hard species has quite strong fibres which are commensurate with jute or flax or hemp, other natural commercial fibres. So there could be potential in synthetic materials, biodegradable synthesised materials that combine the Spinifex fibres with some other type of medium. And that's what the bio-nano engineers are looking at. Okay, well, I've got more samples coming down for you from camel wheel soon. They might be a bit greener, actually.
That's good. The moisture content will affect the mechanical properties. So,
The big picture plan is to build a cleaner, greener infrastructure industry in remote Indigenous communities based on refined Spinifex products.
We would see small settlements of Aboriginal people all over the desert areas having this capacity to harvest every couple of years or do rotational crop harvesting every year in different parts of their country in good seasons, and providing processing plants with regular yields and the material then being taken to the East Coast for use in factories.
The next part of the research project is looking at how to harvest the Spinifex. The most environmentally friendly way to do that would be by hand. However, if it's going to be a commercial venture that's a success, by hand won't be an option.
And there's 30% of the continent's a lot of coverage, and we don't want to see the dust storms that were seen in Sydney and Brisbane last year being increased in number by our harvesting. So it's very important to get it right, and we want to try to develop a harvesting franchise. But there are different ways the Spinifex propagates itself. It can do it by seed, and it can do it by regrowth from its deep roots. It can do it through spreading out runners. And we have to understand which species are depending on which types of these methods and under what climatic conditions, and to be very secure about ensuring that it'll quickly regrow after it's been harvested.
You know, we don't want to see it being too commercialised, where big companies are buying it out and taking the money away from country. You know, it's another industry that we're looking at rather than just mining. You know, we need to look further than just what's on tap right now. And it's, you know, we've used it for that long and it's supported us for that long, so we intend to bring it back and use it that way. But, you know, we don't want no handouts either, so we want to make sure that it's done properly where we have an everlasting benefit from it and it doesn't get, you know, pillaged and misused and they take it all away and you're fixing up country after it, you know.
For the most part, though, the modern science world and the traditional ways of the Delangi people seem to be on the same page.
Well, the exciting thing for me is learning from the thousands of years of work that has already been spent on these materials, and they're obviously useful compounds and combinations and mixtures. So learning from that is exciting, and also we have an amazing array of high-tech sophisticated equipment that we can characterise these materials with. So we're giving it a modern perspective as well, and then joining somewhere in the middle, I think.